I'm going to be building a minimum spanning tree from an undirected graph using Prim-Jarnik's algorithm. So here is our undirected or bidirectional graph. So with Prim-Jarnik's algorithm, you grow the minimum spanning tree from a starting root vertex, and I've used V1 as that. So we begin with this root vertex in the little initial cloud of vertices. And then, so for each iteration, we're choosing of all the edges that kind of go out from the cloud to non-cloud vertices, we choose the edge with the minimum weighting, which here of 4 and 5 is 4. So we then pull V4, that next vertex, into the cloud, and we repeat the process. So here we're looking at, we're actually choosing between 3, 5 and 8 because we'll be using some sort of queue with all of the weighting labels, similar to Dijkstra's algorithm. So of 3, 5 and 8, 3 is the smallest, so we bring V3 in. And now we're looking at 4, 5 and 8, and of those values 4 is the smallest, so we bring V2 in. And here we can see that the edge between V1 and V2 is dotted, so it represents that this edge is not going to be used in our minimum spanning tree. So now of the two edges that are coming out of the cloud, they're both 8. I guess depending on which data structure you're using, I'm going to pull in whichever of these two were added into the queue first. So we'll be using V5. And because there would be 3 edges coming out of the cloud, the one that's weighted 8 and one that's weighted 2 and one that's weighted 5, but because 2 and 8 both point to vertex 6, 8 is not important anymore because 2 is much smaller. So that 4, 8 becomes the dotted line. So now we're just considering between 2 and 5. 2 is smaller, bring in V6. Between 5 and 6, 5 is smaller, bring in V8. And again, because this weight of 6 and a weight of 1 and the edges are both pointing to V7, we go with the weighting of 1. And that is our completed minimum spanning tree.